Hello everyone. Thank you for coming. I will talk about cost reduction strategies in Appengine and Datastore. So the story is that around 1 year ago we went live with our first Appengine product, and since then we have made some changes to reduce the operation cost. So this is going to be a short presentation about the top 3 changes we did to our architecture in order to run it cheaper. This is based on an article I wrote for the PaperCut blog. I can share the article later in the presentation. It goes deeper than this, so if you are still interested on it, you're welcome to come and check it out. So what I'm going to do today is, first I'm going to give you a brief introduction to the product I'm talking about. Then I will show you a little bit of our initial architecture and the changes we made to it to make it run faster. This presentation is not gonna be as interactive as the previous one, and for sure no robots, but it's more about architecture. All right, so my name is Andrés Castaño. I come from Colombia. I've been doing software for around 15 years. In the last 2 years, I've been doing things on Google Cloud, in the Google Cloud platform, mostly on Appengine, but we basically use a lot of other APIs in there. Currently, I am working for PaperCut. PaperCut is a Melbournian company with around 18 years in the market. We have offices in the United States, in London, and the headquarters are here in Camberwell. We have 50,000 clients around the globe. We have big names such as NASA, Harvard, Cambridge, Starbucks. Here in Melbourne we have Melbourne Uni, we have Swinburne, and we do print management software. So, as I always say, it is a very cool company in a not so cool domain. But we've been pretty successful at that. We've been helping companies reduce the printing waste for a long time, and then has worked out so far so good. So this is just a little bit of a disclaimer, just to be, all of us should be aligned and to give a little bit of context of what I'm going to talk about. This is by no means an exhaustive list of things you should consider when reducing costs. This is just the top 3 things that have been more effective for us. And the idea with this is that if you happen to be doing something on Appengine, or you are considering using Appengine for something, maybe for an application or a product, maybe these 3 tips can help you. Because we wish we knew about them before starting doing this. So, the better resource for you to check and to see how can you scale an Appengine application or a Datastore application is the official documentation. It's pretty good, it's pretty extensive, and they talk about coding practices that you should consider when scaling these sort of applications. Having said that, I won't repeat those things. I will try to focus this talk on the things that are not so explicit in the official documentation. Maybe you can infer from the documentation what I'm going to say, but it's not explicit at all. So I won't talk about concepts like sharding, concepts like the entity groups. How do you create entity groups, or how do you stuff that is a good use of caching. All of that information you can find in the documentation, so I'm not going to talk about it. I'm happy to discuss it afterwards, or if you have questions, but it's not the focus of this presentation. And the last thing is that our application could be seen as an IoT application. It's not an IoT as such, but it's very close to it. And we have some similar patterns with IoT applications. And IoT Core was released last week. It was private beta, now it's public beta, and we are actually considering whether if it is a good fit for us or not. Having said that, our current, at this point we don't use IoT Core, but for what we know at the moment, had we used IoT Core, the patterns I'm going to explain are going to be more or less the same. They won't change. They shouldn't change too much. Alrighty, so this is the product pay-per-cut views. The important thing about here is that pay-per-cut views is free. So pay-per-cut offers this product for free for anyone who wants to use it. Therefore, saving cost in operation, saving operation cost is important. So that's one of our main focus when refactoring. It's just just for you to know, it's a printing analytics, printing insights and supply forecast product that you can use. It's targeted to small and home offices. So the very important thing here is that it's the first cloud-native product that we developed. So there were a lot of learning, but also there were a lot of assumptions. For pay-per-cut, for our company, small and home offices is also a new market. So we were assuming some things in the product point of view, also as well in the technology. So, turned out that some of the assumptions that we had in the technology, from the technology point of view, were correct, many of them, but some of them were not so correct. So we had to do some refactors after we released our application, and then this is what I'm going to talk about. So the application is running on Google platform, particularly on Appengine standard environment. You know, there are two flavors of Appengine, flexible and standard. We decided to use a standard environment. It was an assumption we had, and at this point of time, I can say we ratified that assumption. I think it's a good idea to use a standard. Again, outside of the topic of this discussion, whether we should use a standard or flexible or container engine or whatever else, but I'm happy to discuss them. I won't talk about that in this particular time. Right, so this is how pay-per-cut views works. So this is the component that is on Appengine. When it was deployed, it was a monolith, so a single Appengine service running in the cloud, but just for context, we have some software installed on the premises of the client. So for us to know information about the printers, we need to have something on there, and then that is why we think this is sort of similar to a Internet of Things applications. So basically, the client installed on premises will query the printers for information, and then we'll send that information up to the cloud in the form of events. So we have multiple clients, multiple organizations, multiple devices per organization, basically. But all of them are sending events to our cloud application. And this is also important for the context. Sorry, I know that you shouldn't care that much about printing, but for the sake of the presentation, it's important to note that what type of event we send. We send things like someone printed something, the toner level changed, the tray was opened, the printer went in error. And then we take all of those events, and then we process them, and we aggregate them, and then the user, when the user logs in, he will see a nice dashboard with all of the aggregated data from the events. And the dashboard is pretty, when we released the application, the dashboard was pretty live. So every time someone printed over there, you might see things moving in the dashboard.
So is this a hardware that you put in?
No, this is software. You need to install it in your computer.
So is it on the?
You can put it on a print server, or you can put it on, or you can put it also on your own local computer.
Okay. So the printers it will query the printer. It's a pull mechanism or it's a push mechanism. Do you expect printers to send?
This is polling. Again, outside the topic, but this is polling. We detect the printers on the network. We poll for the printers, and then we actually periodically query the printers. Yeah. Yeah, I'm sorry. Happy to discuss this afterwards. Yeah, but we will focus on this, right? So again, monolithic application in Google Appengine, receiving a lot of events, and then aggregating the data, storing the data in Datastore, And then when someone logs in, the data from the data store, which is already aggregated, will be fetched and presented to the user. So the assumptions we had in there were, all right, so cool. So we have a lot of clients, a lot of printers sending sending events, and so we will have a lot of events. And in fact, we have, I mean, it's not huge, but at the moment we are around 100 events per second receiving in our web application. So that's a lot of data. So every time I receive an event, I need to query something in the data store, modify it, and store it again. So before going live, we went and we say, all right, so what we have to do is we need to be careful with the I/O, because I/O will be expensive, because there will be a lot of events coming, and we need to fetch and write, all right? So we developed application, our first application in the Google Cloud, our first application on Appengine, and we optimized for I/O. And then we got the first couple of invoices, and the invoices look like this. So as you can see, the instance time is way more expensive than any other thing in the Google Cloud platform, right? So when I say data store, the data store, I'm aggregating the I/O operations, read and write, plus the storage. And then we say, all right, we might need to optimize for something different now. And then we said, okay, so let's start planning and let's start making changes to try to reduce the instance time, which is the most expensive thing at this moment in time. Again, I'm not saying that this is the same for all of the cases, but it was our scenario. A lot of events, the event contains not much data, like just a JSON file with some data on it, but many of them, and then the problem was the instance time. And then we started thinking, all right, how do we reduce that?
How many clients are there?
So I forgot at the moment, how many do we have?
18,000 active. At 18,000 a day, yeah.
Yeah. So, so cool. So what we have then is, this is like a zoom in to our architecture, right? That was the thing that we used to when we went live. So basically, so I will give you an example just to clarify these two big squares in there. So when an event comes, for example, someone printed something, then we have metrics in the dashboard, and we need to calculate metrics such as, all right, the ratio between duplex and simplex, or the ratio between color pages and black and white pages, or the total number of pages printed in the last day, the last year, the last month, right? So, and those sort of calculations can be done at a printer level and also at the organization level. So you know the ratio, the black and white ratio for this printer, but also you can know the black and white ratio for the whole organization. And so every time an event comes, let's say someone printed something, then I go and I fetch one big data store entity that we have. So we decided to do one big entity per printer, for example. So in that case, because this is a NoSQL database, we thought, all right, so we can have the whole graph we'll have the whole document with all of the metrics in a single document, and we store it. In that way, when I fetch the printer document, I can modify all of the metrics at the same time and then store it again. So we are optimizing for I/O. And so when the event came, we fetch that big document with all of the metrics. We update the different metrics they have, color versus black and white, pages, history, and a lot of things, and then we save it again. But that is for the printer level. We needed to do that for the organization level, so the whole thing had to be wrapped in a transaction. So taking that thing out of the printing environment, what we have there is big documents that need to be modified, need to be fetched and modified in a transaction, more than one document, every time something happens. Right? So that's more or less the generic thing that we have in here. So what is the problem with that? The problem with that is that those documents, because they are big and because they can be modified by many events, they become contention spots. So basically, multiple events could be modified this document at the same time. or more than this one, the organization one, because they have multiple printers, so multiple events can come to the organization. And the problem is that because this isn't a transaction, the data store have a mechanism to protect against that, and it's called optimistic locking. So basically, if I try to save, if I fetch a document, I modify it, when I try to save it, the data store detects that there is a model modification happening, then the whole thing fails. And so what we had to do was that in our Appengine instances, what we were doing is retrying, right? So I fetch the document, I try to modify it, and I try to store it, but if it fails, then I need to retry the whole thing. I fetch again, modify, and store, hoping that the second time there is nothing modified in the document underneath. But if it happens, I need to retry again. So basically, the main point of the majority of the time of the instances was spent trying to retry savings on the data store. So trying to retry, retrying optimistic concurrency errors. So we said, right, we need to break that. We need to stop that. We detected, we saw, how did we know about that? Because of the logs. The logging, the Stackdriver logging system that Google Cloud Platform provides is awesome. So we know that there were a huge amount of error. So we didn't caught that because we didn't catch that before because the data was consistent. Eventually, the transaction will commit. So we had the right data, and the user will see that we're seeing the right things, and we loaded the thing a lot. And eventually, when I opened the dashboard, the user was able to see the right data. The data was precise, was correct, but the instance was just running, trying to store it, and retrying and retrying. So the other thing is that because we stored all of the information for a single organization or for a single printer in a document, then the documents were big. So Datastore has a limitation of 1 megabyte of size in the entity to store of 1 megabyte. We were reaching that limit in some cases. So also that made slow to fetch the entity. So the first change that we did, and this is the first learning that I want to share with you, is then we took those documents and we split it apart, and then, all right, so we have one document per metric. So color versus black and white, one document. Duplex versus simplex, one document. Printing history, one other document. Different documents. So that when an event comes, I need to fetch multiple documents, but the documents were smaller, and therefore the contention was much less. So in this case, we sacrificed I/O. So we have more I/O, but the document is small. And this is basically the first learning for us is don't underestimate the contention. High contention can cause instances to retry, and then more time is spent saving than, and at the end it's more costly than actually having more I/O. In fact, because in the past we have a tree of data, we have the printer and then a lot of metrics underneath. The data was shared, so the common data was put at the top at the root of the tree. Now, since we split it, then we need to put more data in the individual documents, and we are storing more data. We are actually putting more data and more I/O in the data store. But even doing that, the time that the instance took to commit the transaction was less. So yeah, this is the first.
Sorry, question.
Okay, go ahead, please.
So what happens if you fail at the last transaction? How do you roll back to phase 2?
If I failed this one?
Yeah.
Well, the other benefit is that I had to put transaction on each one of them, but because this transaction involved only one entity, then if I failed, I just need to retry this one. The chances for this entity to fail due to optimistic locking are less than in this case, for example, in which I have multiple entities in the same transaction. So any one of them who has any entity inside a transaction that gets modified before saving, then we'll make the whole transaction to roll back and retry. So in this case, because it's we try to put smaller documents in a single transaction, and that is basically the next step. So these things work fine, but in this case, we still had that problem, the one you mentioned. Try to modify this entity, perfect, commit. I haven't commit yet because I need to commit the whole transaction. Then I try to modify this entity, and then this entity actually failed because of optimistic locking. Then the whole thing rolled back, both entities. So, and this is just a reduced set of things. In a real application, we have a lot of entities that needs to be modified in the single transaction. So still, even though we had less optimistic locking errors and less retries, still we had some. So we need to go to the next level. And this is the second learning that we got from there. We break the cross-group transaction. This is called a multi-group or cross-group transaction, when you have multiple entities belonging to different entity groups, and you try to do it in a single transaction that it's a two-phase commit, which is slower than a normal commit. You need to put the entities in the same entity group. So we broke that. No more cross-group transaction. So how do we fix it? So we actually relied on domain-driven design principles and that thing called eventual consistency. And what we did is, all right, so what we have to do is that, fortunately, we have PubSub and task queue. So what we did was, when the event comes, we put the event in PubSub, or we put it in task queue. Initially, we used task queue, then slowly we are migrating to PubSub. And then each one of the metrics, so these two metrics needs to be in a logical transaction. The same event will modify two documents. But the good thing about this is that because these things are independent subscribers of PubSub, if we modify this one and this one commits, and we modify this one and this one fails, PubSub will make sure that the whole thing retries. Right? So we don't need to retry all of the entities in the same transaction. We do it in independent transaction, and we guarantee that the data is committed eventually. So probably these two things won't get to the data store at the same time. Probably this one gets retried because this one is more likely to have contention for any particular reason. Doesn't matter. We commit this one, and this one goes and retries independently without affecting this one. This, until now, is the most effective change we've done to reduce it. We almost eliminated completely the optimistic locking errors, and the retries is almost gone. There are every now and some errors, but because we have small documents and we have independent transaction, one document per transaction, the chances of collisions or the chances of optimistic locking is very slow, very slow. So as a side effect, of course, we have better segregated logic. We have independent documents that doesn't relate to each other, and also, in some cases, if I have a metric that depends on other metrics, this particular metric, the second metric doesn't need to be modified if the first metric is not modified. So to solve that, we use event change. We get this event from the client. This guy subscribes to the PubSub, gets the event is processed, and if this metric detects that there is a change, then I can put another event to the same PubSub. So another metric, another document or another part of the application that requires this metric will react about it. So the benefit of that is, of course, that the other metric that is listening for this event won't be fetched if this metric is not modified. So we save also in there.
What have you got this week? You got data flow this week for processing the events?
No, in this particular example, we actually we have an API that manually puts the events in PubSub.
What's consuming the events from PubSub?
These are just at this point of time, the application was a monolith, so we have just a push endpoint in the monolith from PubSub.
Right. Okay.
So
Yeah, just Appengine instance.
yeah. So yes, I'll get to data for later. So this actually gave us the opportunity, and then we saw this after seeing this, then we saw, oh right, so it turns out that this and this are completely independent things. And thanks to Appengine and how powerful is the Google Cloud Platform, we were able to say, we can put this in another service. So we ended up splitting the whole application, the whole little things into multiple services in the Google Cloud. So we ended up with a bunch of services instead of a single monolith. And then you would think, yeah, but then that increased the cost. The reality is that if you split the services and you tune them up properly, actually the cost goes down. And the reason is because not all of the metrics or not all of the services require the same profile. So basically you can put the metrics that have a lot of transactions, you can put better instances, better Appengine instances, or more expensive Appengine instances. But the ones that doesn't require that much processing power, then you can reduce and use a cheaper instance. Therefore, you are optimizing at the instance level and saving at the end. At the long run, you will save costs because you don't need all of the instances. You don't need a powerful instance to calculate all of the metrics. So metrics that are not that important, you can have a less powerful and cheaper instance. Also, the other benefit that we had in here is that it gave us more clarity about what we were doing, and then we were able to choose different languages depending of the requirements of the service. So for example, we use Golang for our gateway, for example, because Go as a runtime is better. It has a smaller memory footprint than Java, and it can handle more requests per second. But Java, on the other hand, has better tooling. So for transactionality and for data store access, Java has better tools. If you've heard of Objectify, that is an amazing thing that handles all of the retries and everything for us. But Go doesn't have that. But when it comes to handling requests, Go is faster. So for the gateway, for example, to handle the 100 requests and authenticate the request, we actually just do a little bit of authentication on the request and put in the events in the PubSub. We use a gateway written in Go. And in the past, we were doing that in Java. Therefore, we had more instances in Java doing that thing. Since we split it and we put that in Go, that load was transferred from the Java service into a Go service that is more efficient for that. Same for the web gateway. So splitting the application in multiple services gave us the chance of optimizing or tuning up the services individually according to the task that they were performing. Also, we realized that, and then because of this, we have more clarity and more visibility about what we were showing in the dashboard. And turns out that we didn't need to have everything live in there. So some of these services, instead of doing calculations every time an event comes, those services calculated in a batch mode. So basically, this is outside the topic, but we are streaming events directly using Dataflow to BigQuery, and periodically we are calculating the metrics and store it in the service. So these services are slept all the time. We put data in BigQuery and read it from BigQuery periodically, every hour or every half a day or something, to update the metric. And that was thanks to the fact that we were able to split the services. This has been also a huge change for us, and we haven't finished this. We are still extracting services from the monolith and putting them outside. And also, just for fun, we're using Kotlin in one of the Appengine services, and so far so good. So I think the next services we will be using Kotlin instead of Java. I mean, they have the same tooling, the same libraries, the same performance.
Does that make it harder? Or maybe it's a question for the end. It's a bit of a broad, but does that make it harder to work to have so many different languages? So it's harder to scale your team.
But yeah, So that's another problem. We will discuss it. Yes. No, we're trying to stick to two languages, Kotlin and Go, and we are moving out from Java to Kotlin. And we are using already Java 8 in the standard environment. Super nice. It was released this year. So, yep, as a summary, so then we have three big things. The first one is reduce data store constellation, split documents, don't store big documents. It's better to have duplicated data than huge documents in the data store. The second one is remove multi-group transactions, use eventual consistency, use PubSub, use TaskQ. There are cheap things in there. And the third one that worked for us was splitting the whole thing in multiple services. that was it. Yeah, I'm happy to take any questions if you guys have anything. Yeah.
So, assume that multiple PCs are connected to the same printer, and we should install your client application on each PC.
There are two configurations. You can do it on each PC, or if you have a print server, you do it in the print server.
Oh,
But it could be in any PC, right? So we have a sort of a, what was the name of the algorithm? We actually choose what, we have a redundancy.
Yeah, we got a bit of a voting algorithm.
Yes.
Because, you know, one of the lessons we learned was the customer had, I think, the 200 of the clients running, and it was a you know, a not-for-profit organization, and we DDoSed their system because of all the clients, and we felt really bad because some, you know, the organization was for, you know, people with disabilities. So we felt really bad. We gave them, I think, a free license to some of our other software. But so what we implemented was kind of like a voting algorithm that we would start detecting like the more reliable clients that are like calling in, and just start picking up events from them instead.
Do you have like a team per service?
Yeah, we have at the moment, we have a person per service. No, we are a single team. we're a small team.
Everyone
Yes.
doing everything? Or?
Yeah, at the moment we're touching everything. So we'll see how it's scales. It's our approach. We feel at the moment we're comfortable. Of course, yeah, introducing the new language was actually a team decision. We decided to bring Kotlin in, and yeah, we are not imposing the languages. It's more of, we have a base of languages we can use, either Kotlin, Java, or Golang. We favor Kotlin or Java.
Do you have ordering on your events? Does the order of the events and the order that they come in, is that important to the way the system?
Yes, the PubSub doesn't guarantee ordering.
No.
PubSub guarantees at least once delivery. Is not ordered, but even can be duplicated. In some cases, you can have the same event twice.
Yep.
So, yes, we are protected against out of order events, and we are protected against duplicated events, but it's our
internal to the
code.
code,
So
yeah.
we put it in the code. We are using Dataflow to stream events into BigQuery for the asynchronous or batch metrics that we do. We can do some sort of a deduping in Dataflow if we use the proper window. So we can put window in and do some sort of dedupe and ordering of events based on a property of the event. Paul here can explain better because he was working on that. Yes, please.
So you mentioned you use Go for the gateway thing,
Yeah.
and it doesn't really handle a Go or anything like that. So does that mean you've got it set up that when things come in,
Yeah.
that may be relevant to a particular customer account, you can fire it in without having to worry about what the customer account, which account is going to, and then that's all handled through whatever service
Downstream
picks up
service we
and
have. Yeah, for this particular case, yeah, so for this particular, and this was a policy that we decided to do in our team, might or might not be correct, but that was what we decided. We do authentication in here. So in here we know that whoever is sending the event is who he claims to be. We use JOT tokens for that. And then we get some information out of the JOT token, we put it on the header, and then the authorization happens on each one of the services. So being sure that this customer is able to see this metric is happening in the services, being sure that the customer is who he claims to be, or sorry, that the printer is who he claims to be, happens in the gateway.
Right, so, and you're using Java tokens or sorry, whatever tokens.
Yes, tokens. Java token, yeah. Not Java, but JSON based tokens.
Yeah, we're also using pretty heavily using memcache. You know, so just doing them like through caches, and you know, if there's kind of like shared keys and things, which obviously also helps with the costs, things like that. You know, so if you got a whole bunch of events that are being authorized against a particular client, you don't have to keep on fetching the data to the client's games picked up the memory.
Right, and hence you don't need to access the database.
It's the latest stuff, yeah.
Yeah.
So I mean, we use a lot of caching. We use we actually do some sort of sharding. Sharding is a little bit of a complicated topic in our case, but yeah, we do some sharding as well. But all of the things that I'm saying are on top of the memcache and sharding things.
Do you see any room in your architecture for using something like cloud functions?
Yes, actually, this product is live already. We are still growing the product a little bit, but not so much. We are now building the rest of the cloud products that we're going to have in PaperCut. And for them, yeah, definitely, the benefit, and this is an inherent benefit of microservice architecture, is that you can actually theoretically, you can take this and replace it with something else, right? So yes, we could use cloud functions. We are evaluating it because these services could be pretty hot, meaning that it will be all the time receiving events. So we will have a cloud function on all the time. So maybe we need to evaluate if cost-wise it's better to have a service running dedicated service than having a function on all the time. But yeah, it's something that we are definitely evaluating.
I think the language also has something to do with it, right? Like type safety and.
Yeah, I'm not a huge fan of JavaScript. But at least my background, I'm probably wrong.
Or you're not living on the edge, but
Just wondering, how does the cost compare before the optimization and after?
Yeah, so so the metric is a little bit tricky. We're still fighting how to get a good cost metric because the invoice hasn't go down, but also we are getting more clients every month. So we're getting more events, and then the invoices are more or less the same.
Well,
so we were
go ahead. Yeah.
So we were thinking that maybe we were trying to get a device, a cost per device per year. It's a difficult metric to cut. Devices printed, cost per printer per year, and we have gone a bit more than 50%.
You had a ratio before that. It was like 90%, was it?
Well, but that's the ratio. That's the ratio of the instance time versus the storage. Yeah, I don't have the ratio after that. It should have gone down. Still, instance time is the more expensive thing by far.
Yeah. Well, I mean, it's even more than 50%. I mean, I think when we first measured it, we were at like US dollars $1.80, I think, the device. Now we're on, I think it's 56 cents, US cents for the device a year. So
yeah, more than 50%.
Is there any the time consideration for those the print events normally happen in the daytime, like in working hours, but outside of that time, there might be less requests?
Yes, absolutely. Our client, the thing that's installing on premises, has two performance modes. So after hours, it goes to more of a dormant mode, in which we actually send less events, and also on the weekends and holidays. Yeah. So yeah, the biggest change that we have is that we've reduced the rate of events, and then that's it. It's reduced a lot of things. But on top of that, with these changes in the cloud. But yeah, that is absolutely, yeah, that's what we do as well.
Question, with your clients, how do they authenticate against the gateway?
How do you authenticate with the gateway?
The clients that are, let's say, running on the multiple machines.
Yeah.
How do they actually authenticate? Do they?
So basically, when you install the client, there is a little bit of a handshake happening. So you actually go try to identify yourself. We have we fetch the identity. We validate that the client belongs to the organization, because when you don't know the client already has a key auto-generated at the moment of download. So we do some sort of a handshake, and at the end, the client will have a authentication token, a JOT token, with some information on it. So that JOT token is attached to the authentication header of each request, and in the gateway, we get the JOT token and we validate that the token is a valid token and it's still on and it's not too old and stuff like that.
So if a customer has multiple clients,
yeah,
they all have the same token?
No, different tokens. Each one token. The token is sort of a signed base 64 string, right? But so each client has its own ID, but multiple IDs can belong to the same organization. So the client is unique, but when we get it to the cloud, we can identify that client as part of the organization, so that we can fetch organizations and print it and stuff.
Just following up on that. So do you only authenticate once, or those tokens are
Every
expired
call.
and keep on?
Every event that is sent contains that token.
Yeah, but I mean, like, how do you retrieve the token once, or do you refresh the tokens?
When we install, we retrieve the token once. But when we have a mechanism to reconfigure the client, so we can actually periodically. I still don't know if we do it, but we can refresh and restart the client and force another token to be fetched.
What about failure scenarios? What about failure scenarios? Let's say a client and a machine crashes and you have lost a bunch of events, which cannot be reported to the cloud platform.
So that's part of the architecture of the client that goes on premises. So basically we store a lot of events locally. So we have multiple services running in the client as well. It's not a single service, we have multiple. One of them is monitoring the queues on the network. So basically that thing, the only thing that it's doing is getting the data and put it in a file. So if the main one that sends the events to the cloud fails, we have a bunch of files in there that needs to be, so when the thing comes back again, it catches up and reads all the files and sends them. If the one that is monitoring the network fails, then yes, then that particular client won't monitor.
Yeah.
But that's why we have a redundant architecture, so you can have as many clients as you want. So for you to lose data, you need all of the clients to go die, to actually fail.
So are these like distributed data systems, meaning clients can talk to?
No, at the moment they cannot talk. We have the capability, but we don't talk at the moment. But yeah, I mean, yes, we don't do it at the moment. Probably that could be even a safer path to have to synchronize between them which one is monitored at any particular point of time, and if one of them goes down, then the other one can take over.
It's like a cluster architecture where you have a cluster of clients and the data is shared between.
Yeah, we could do that. We don't do that at the moment.
I didn't think you get so many questions about Microsoft.
Yes, actually, I thought we were going to focus on the chrono. Yeah, good. All right, thank you very much.